One of the easiest ways that you can talk about finding the domain and range of continuous graphs is I can ask myself, can I make a frame? If I look at question number 2, I can make a frame. I can make a frame all the way from here, along this line, and along that line, and along that line. It's the green area. And I can make a frame. And that will give me my minimum and my maximum. Number 1, though, I can't make a frame because of those arrows. So that kind of lets me know that I can draw a line here, the minimum at the minimum point. So that lets me know that one of these values, either my domain or range, are going to be all real numbers. Now, if I look at number 3, okay, if you notice, again, just like number 1, we have arrows going off into infinity. And really, this line goes on forever. And it basically covers all of the x values, all of the y values. There's no minimum or maximum. As you can see, like in question number 1, I have a minimum point there. And even question number 4, I have a maximum point there, because my arrows are going down in the opposite direction. But because of number 3, they're going in category to each other, then they're still getting bigger and bigger and bigger. So the domain and range of this one is going to be all real numbers. So whenever you see a line like this and it has a slope, you can say all real numbers. Number 4, if I take my pencil left to right, because these arrows are pointing down and our graph is getting wider and wider. We can't really determine that or really deduce that from the window that we're given, but we know that this is a parabola, so we do know that it's going to always get wider and wider. So in a sense, this domain is going to be all real numbers. And that's a pretty standard rule for parabolas unless they're cut. So like if I broke this parabola up and I say ended it there, then that would be a different situation, all right? Now the range is very much like number 1. And that was funny. My cat just kind of like went cuckoo for Cocoa Puffs. Anyways, the range here, I said that's the maximum value. Well, what's the y value? We've got y, because we're looking up and down. So the y value, the maximum value there is at 1, 2, 3, 4, 5. Since we know it's a maximum value, then we're including all of the y values down below that. So that's all the way to negative infinity. So our range is going to be y less than or equal to 5. Now, there's another way that you could talk about it. You could say negative infinity less than or equal to y less than or equal to negative 5. That is another way that you could talk about it. So the values of y are in between negative infinity and negative 5. Y is less than negative 5 is going to be the more common way that you're going to see it for Algebra 1. All right, let's do number 5. I'm going to do that, like how I said I could make a frame. So number 4 and number 3, I couldn't make a frame. But number 5, I can make a frame. If I make a frame along where it's hitting my graph, just like this. And I'm using a solid line because my graph line is solid. So all of my x and my y values are in that area that I have just shaded. So my domain, my minimum domain is negative 1. My maximum domain is 1, 2, 3, 4, 5. So, and it's going to be less than or equal to. My range, my minimum range is going to be down here at negative 3. And then my maximum range is going to be up there at positive 3. And technically we should be using our braces, but I'm not going to count off for that. I'm not too worried about that. Number 6 is very similar to number 3. Don't get bogged down, but even though there's that curve and you have a maximum there and you have a minimum there, because these arrows go on to infinity in opposite directions like they do in number 3, both the domain and range are going to be all real. All right, I will see you in the next video where I will continue going over some problems. See you then.